Es ist 12:29 Uhr.
Hi there, it's time to play with junk again. Today I will show you how I built this Wimshurst electrostatic generator. Some of you may recognize it from my short video. I made an ESD machine, and well, let's see what's inside and how to make one. Let's start with the frame. It's pretty easy. The base is a big thick board, wood, then two columns that support the whole structure. It's just glued here. There are no screws, nothing. And then we have the drive mechanism with the crank, with the hand crank. That's here. And that's basically one shaft that goes through to the other side. There's a ball bearing here, and there is another ball bearing here. And because the shaft was a little bit too long, I added some washers here, and the whole thing is then clamped together so that everything spins when I spin the crank. So that's the crank. It's a little wooden wheel. You can find them in a hardware store. I found it here locally at the Bauhaus. These are wheels for furniture or something else, and the two other wheels here I made a groove for these rubber belts. And the rubber belts in themselves, they're not really rubber. You can see it here. It's rubber. It's a rope, an elastic rope. And I just glued it together with super glue. And then I took my soldering iron to close this fabric here. And I see I have to do it again, so the glue is still intact, more or less. Yeah, it could be better. I think I repeat that again. Next part is this, or are these two wheels here. They are made of acrylic glass. I call it plexiglass. It's just a round disc. It's about 3 or 4 millimeter thick. And it has these sectors here. That's just aluminium tape. It's some self-adhesive tape. You can cut it into pieces and stick it on anything. So you can also find that in some hardware stores. So we need 24 sectors for each disc. And then in the middle we have a hub with 2 ball bearings. I made this of aluminium with a groove here for the rubber belt. You can make that of wood, of plastic. Ball bearings are nice because they provide a low friction bearing, and but if you don't use it too much, so a thing with a precise hole and a little bit of grease may be okay too. So I did the more luxurious way. I have 2 screws here to attach the disc to this hub, and of course I made it 2 times because we need 2 of them. And as always, when I assemble something, I forgot to put this rubber belts around the spinning wheels, so I have to disassemble it again and assemble it again. You may have noticed that one belt goes straight and the other one goes over cross. So the idea is that both discs spin in opposite directions. That's important. Which way they go is not so important. It depends on when we assemble the rest of the machine that we do that right, but if it goes that way or that way, it will work either way. But I decided to go clockwise. The next part we need is this neutralizer bar here. It's just a piece of thick copper wire soldered to this plate with a hole inside to put the screw through, and then I soldered some extra fine copper wire here, the same on this side, and that will brush on the disc, and I will show you how this is attached. Okay, so the best result is to have it in about a 45-degree angle, measured to the vertical or horizontal line. You can adjust it to be a little bit steeper. I think that gives you a higher voltage, or a little bit a flatter angle that gives you more current, but as a nice compromise, 45 degrees is not bad. It goes that way when the disc turns clockwise, and I will explain what this does in a minute. Let's just attach the other one to the other side. And this is now spinning also clockwise, because I turned the whole machine 180 degrees. So I go again 45 degrees like so. Now with this setup here, I'm already generating electrostatic energy, or electric energy. Make sure that first of all these screws are not tightened too much, and that the brushes only just touch the surface here, because if they create too much friction, it won't turn correctly. And you may already hear it. It's this crackling noise. That's a lot of static electricity, and you can feel it, or you can probably hear it. If I touch these segments, they are all charged like crazy, but like this, the machine does nothing. It just charges these sectors here, and that's not what we want. We want to create sparks. And to collect all these sparks, I made these spark collectors here. You may notice they have some tiny teeth here. They are also made from this aluminium foil tape. And they will go around here, and they collect all this static electricity from these individual sectors there. And this doesn't need to touch the sectors, but these spikes here, they will take up the static electricity and transport it to here, which is connected to this rod, which will then be connected to the inside of these tubes. You can see the outside, that's just aluminium foil. Inside is also aluminium foil, and they are connected together, outside to outside. That means these two capacitors, yes, that's a capacitor. It's two metal plates separated by this acrylic glass tube, and they are connected in parallel. So let's screw them to the board. And for that I need an extra long screwdriver. Let's see if I can do that with the camera here in the way. Yeah. It's always nice to have pre-drilled holes, so makes things much easier. And the installation of these collectors here is pretty easy. Everything is prepared because I used it before. They just slide in here, friction fit. Okay, let's see. Yes, everything runs free. I just run in the wrong direction. And of course, there is another one, identical one for this side. Let me straighten this tips here. Okay, let's see. Yes. Okay. That's pretty much it. Let's see if it works. Of course, that machine wouldn't be any fun if we couldn't do any experiments with it, so I made this little thing here. It's a wooden board, 2 plastic stands and 2 bells from an old telephone. And then I have a piece of aluminium foil. I made this ringer here that is on a wooden stick, and then on this paper that acts as a turning point, as a pivot point here. This part is well insulated as well as the 2 bells here, and now we connect it to the machine. By the way, static electricity and static discharges have a lot of interesting effects. For example, they disable my microphone here. This Rode microphone has a USB connection, and when I play with my machine here, it suddenly loses that connection and I have to reset it and it works again. So I cannot use this microphone to record the bangs of my machine because it will simply turn off. The explanation is, as soon as the spark jumps here, or maybe here, on these ball bearing balls that I soldered to these copper wires, when a spark jumps, it creates radio frequency. So a lot of electrical noise, electromagnetic noise, because only the static electricity creates an electric field. But as soon as the spark jumps here or here, there's also a pretty large current flowing that creates a magnetic field, and together it's an electromagnetic field. And that's exactly how the very first radio communication devices worked. They created high voltage, put a spark gap on it to create a high frequency noise. Then they used some filters, some capacitors, inductors to select one of these waveforms, and then they put it on an antenna, and the whole thing you had to do is to interrupt that spark, and Morse code was invented. Well, Morse code existed before radio communication, but it's pretty easy to use it. You just turn that machine on or off and you transmit your signals. Okay, that's it for today. Thanks for watching.